So getting into the next little bit, we have the last two kinds of functions to worry about for this course. We have our exponential functions and what ends up being related to those by being their inverse. We have logarithmic functions. Starting with the exponential functions though, what are they? What do they look like? What kinds of special features do we have to worry about? In the same way that we've talked about special features for lines, for quadratic functions, for rational functions, stuff about radicals, absolute values, like what's going on, anything that we can use that is helpful, worthwhile, important in some way, like in applications. So what's the scoop with an exponential function? We're switching things up from the way that we've seen polynomials being built. What we've seen all the way up till now is we take something as a variable, as an unknown, and we raise it to a fixed power. So take an x, raise it to a power of 3. Take an x, raise it to a power of 1/2, aka square root. So we're turning that around. What we're going to do is we're going to take a number and we are going to lock that in. And the power is going to be variable. The power is going to be the thing that changes. Now the number that we pick has to be a particular kind of number. It has to be positive, and it can't be a 1 because that's going to just kind of degrade into boringness. So it's got to be a positive number that is not a 1 so that everything works out in a nice, smooth, aka continuous fashion. What we end up finding is that there are two different versions of the graph based on this base number b that gets selected. If we have a number that is bigger than 1, so a good example to choose would be 2. If we talk about 2 to a power, negative numbers, what happens? If it's a 0, what happens? If it's positive numbers, what happens? Versus if we pick something that is a base between 0 and 1, such as 1/2. If we take a 1/2 and raise it to negative powers, what's going to happen? If we raise it to the power of 0, what's going to happen? If we raise it to positive powers, what's going to happen? And you take a look at these graphs. If we take that curve and reflect it, that's not a coincidence. It's not a coincidence. There are certain special features that we have with those graphs. We can talk about the domain, all real numbers. We can talk about the range, only positives. Never hitting the 0, not with the basic graphs. Y-intercept, 0, 1. 0, 1. Doesn't matter if the base is 2, the base is 1/2, the base is 15, the base is 1 over the square root of 7. Doesn't matter. Y-intercept 0, 1. No x-intercept, because again, the range is always above that x-axis for our basic shapes. But what we have is this horizontal asymptote. Remember that definition said, oh, it's this horizontal line that our graph approaches to the left and or to the right. And with that rational function business, we said it was an and. Both ends were going to get closer and closer to that horizontal line. Just to the left. For this shape, just to the right. Not a both, just a 1. Got close to that horizontal line, off to the left. Got close to that horizontal line, off to the right. So our definition for that horizontal asymptote, thankfully, coming into play, saving us from having to make a tweak at this stage where we see something a little bit more unusual versus what we've seen in the past. So horizontal asymptote, y = 0. Now we can take this sort of stuff, and we can do all the kinds of stuff that we were doing before. We can do graph transformations, pick these suckers up, shift them left, right, up, down, flip it upside down, spin it left to right. Hey, this is already kind of worked out. It's already kind of worked out that way. Spin it left to right. We can stretch, compress, horizontally, vertically. We can do all those sorts of things. We just have new shapes and a new batch of information that we can work with. So we have a little bit here with a couple of examples to highlight that. Starting with the first one, where we only have one transformation. Because we have a base 3, we're going to be starting out with the blue version as our basic graph. Because that power has been changed, that corresponds to a horizontal shift, specifically shift right 3. So if we take our basic shape and we've got that y-intercept 0, 1, we've got that horizontal asymptote y equals 0, and we shift that blue graph to the right, and we shift our horizontal asymptote to the right, our horizontal asymptote doesn't change. Our x value does. 0 plus 3 is 3, 1. And if we wanted to have a little extra detail, if we had a point where x was equal to -1, where x was equal to +1, maybe where x was equal to +2, we can make sure that we've got those other points in there, but this gives us a very basic sketch of what's happening based on just that one transformation. If we had multiple transformations, well, we're going to be interested in what happens to the shape, what happens to the y-intercept, what happens to that horizontal asymptote. Those are going to be key things for us to pay attention to. So we'll look at a new example that's got a little bit more going on. We can map that sort of stuff out. What we are doing is we are going to be working where we keep in mind the order of operations. Our base is 1/3, so we're going to start with that green graph as our basic shape, and it's that same y-intercept 0, 1, it's that same horizontal asymptote y equals 0, and the order of operations comes into play with the fact that we've got these changes with the negative and with the +2. So when we do a calculation, if we pick an x value to plug in, which of these manipulations comes into play first, which comes into play second? The negative comes into play first, so we're going to do the flip upside down first. We're going to take that entire picture and flip it upside down. That means that the y-intercept has moved and become 0, -1, but that horizontal asymptote has not changed. The second thing that ends up happening, though, is corresponding to that vertical shift, up 2. So anything that is y-based is going to be changing by being shifted up 2. Oh, snap. That gets shifted up 2. That new horizontal asymptote, got to bring the picture a little bit more to the right where we have that labeled. That picture showing us y equals 0, add 2, gives us y equals 2. Our y-intercept, 0, -1, is now getting shifted up 2. So our y value, -1, gets added to and becomes 0, 1. Ooh. The y-intercept is back where it started, but the shape is completely different and the horizontal asymptote is completely different. Oh man. But the order of operations helping us keep track of how do things fit together if we take that order of operations into consideration with the transformations. Which thing does the order of operations tell us to do first? So which transformation do we do first? Which do we do second? If there was another third transformation, which one would be done third? That can help us out making sure we're keeping track of stuff. The other thing to comment on here with this introductory lecture on exponential functions is that we have what we refer to as the natural base. E is the number that we are talking about, and we say E because this is like pi. It's one of these numbers that does not have a fraction form. It does not have a nice decimal form. The decimal version of this never ends, non-terminating. It never repeats, non-repeating. So it's like pi in that respect. This is something that was attributed to a guy named Euler. Yes, his name starts with an E. It's also called not just the natural base, but Euler's constant. Is a super duper important number in math, but it is approximately 2.71828. It is a number that happens to appear frequently in models of natural behavior, which is why it got the name natural base. So population growth, radioactive decay shows up in those kinds of things, these kinds of natural phenomena, so natural base. If we've got E, that's going to be more like that blue picture because that is a number that is bigger than 1. So that's going to have a picture like that blue basic shape. And that's just one of those other base numbers that might show up along the way and might be something to worry about as well when we eventually get to talking about that other topic that is related to these, that logarithm business.